This is a good example of a two-dimensional problem involving Coulomb's law. And here we have charges arranged as follows. We've got two positive charges along the x-axis as shown. One's 4 microcoulombs, one's 6 microcoulombs. And then straight above the 6 microcoulomb is a negative 9 microcoulomb charge. Now if we read the question carefully, they give you the distances, which I've labeled on our diagram, but they ultimately want to know what is the force experienced by the 6 microcoulomb charge. So we're focusing only on this lower right-hand corner. What forces is the 6 microcoulomb charge experiencing? So to start the question, once again we do our free body diagram and label all the forces acting on the 6 microcoulomb charge. If you like, you can imagine the other two charges are nailed down. They're not going to move. And we're going to try and figure out which way the 6 microcoulomb charge would move in this arrangement. That's what's meant by the net force. Which way is the overall force pushing on the 6 microcoulomb charge? Now, I like to label my three charges as follows. So my 4 microcoulomb charge, I've labeled charge A. My 6 microcoulomb charge is charge B. And my negative 9 microcoulomb charge will be charge C. Now let's examine our charge B. What forces are acting on it? Well, we know that like charges repel and opposite charges attract. So there'll be a repulsion between A and B, forcing charge B to the right, and attraction between B and C, forcing charge B upwards. So let's label those two forces as follows. So you can see I've labeled FAB to represent the repulsion between A and B, moving to the right, and FBC represents that attractive force between B and C. So FBC is up, AB is to the right. Now we also know in physics that our net force, our overall unbalanced force, is the sum of these two forces. So we want to add these two vectors together tip to tail. So let's move them around and see what they look like tip to tail. Okay, so let's move FAB over. And to that we're going to add tip to tail FBC. Like that. So our overall net force will be from where we started this diagram and point towards where we finish it as follows. So here we see our F net pointing from the lower left to the upper right. And you can imagine that if we know what FAB is and what FBC is by calculation, F net will simply be found using the Pythagorean theorem. We could get the direction very easily using simple sine, cosine, and tangent functions. So our next step is to figure out what the values of FAB and FBC are. And for that we're going to use Coulomb's law. So here we see Coulomb's law. F is K, Q1, Q2 over R squared, where Q1 and Q2 are the two interacting charges, and R is the separation between the two charges. Coulomb's law, keep in mind, only works for point or spherical charges. If it's sheets of charge, then it will not work. But in this case, we've got point charges A, B, and C, so this is the appropriate formula. Now we want to find out what FAB is, so we're going to label it appropriately. And simply put in Q1 is 4 microcoulombs and Q2 is 6 microcoulombs. R in this case would be 0.2 meters. So let's solve for FAB now. So here we see Coulomb's law with the appropriate numbers subbed in. 4 times 10 to the negative 6 coulombs is the same thing as 4 microcoulombs. 6 times 10 to the negative 6 coulombs is 6 microcoulombs. They're separated by a distance of 0.2 meters. And our constant, 9 times 10 to the 9 coulombs constant, is the K value out in front. And you crank all that out in your calculator and you end up getting FAB is 5.4 newtons to the right. Similarly, we can solve for FBC, the vector that's pointed upwards. And the only thing that really changes is our distance is 0.25 meters, and Q2 becomes 9 times 10 to the negative 6 coulombs. So now that we have the values of FAB and FBC, FBC we've determined is 7.8 newtons upwards. The only thing that's left to determine F net is the Pythagorean theorem, since this is already at 90 degrees. FAB is 90 degrees to FBC. So our last step is Pythagoras, and we can even get the direction using tan theta. So let's finish it up now and see what we get. So to wrap this question up, as I mentioned, we have our Pythagoras. So a squared plus b squared equals c squared, where the c squared will be F net. So F net will be the square root of 5.4 squared plus 7.8 squared, and we get 9.5, so that's the value of our net force. And if I label this little angle here theta, tan theta will be opposite over adjacent, so FBC over FAB, so 7.8 over 5.4. And to find an angle, of course, we do tan inverse to get 55 degrees. So we would say that F net is 9.5 newtons at 55 degrees north of east.